Hello student, very good morning to all of you. How are you? I hope you all are happy, healthy and fine at home. Do you remember what were we discussing yesterday? I think we were discussing about the mechanism involving oxanium ion, and just we have started I think discuss somewhat about the Beckmann rearrangement reactions. So today also what we are going to discuss is look at on a blackboard. See, there is written Beckmann rearrangement reaction. So first of all, let me tell you something about Beckmann rearrangement reaction. Beckmann, as all of you know, that is a scientist's name. He discovered such kind of the reaction and therefore the name is given to that reaction. So what are the starting material he has taken and what will be the product is formed there, and why it is called as a Beckmann rearrangement reaction. Generally oxime, you know that oxime, right? And when that oxime is treated in an acidic medium and the resulting compound is formed is a N-substituted amide, so that reaction is known as Beckmann rearrangement reaction. And oxime means how the oximes are obtained, everybody knows that oxime, when ketone is treated with ammonia derivative like hydroxylamine, and then the resulting compound obtained is called as oxime derivative, and that derivative is the starting material of the Beckmann rearrangement reaction, that oxime. And as we know that the generally when oxime is formed, there is a carbon nitrogen double bond and OH. OH means that OH hydroxyl group is attached to that nitrogen, and that when that ketone, if you look at the structure, if you observe the structure carefully, what do you see? The lone pair and the hydroxy group on one side and other side is a two ketonic groups are there. If the symmetrical one, then we are getting resulting compound is only one product, that is the what we can call it as a single product is obtained. If you talk about the stereochemistry of that Beckmann rearrangement reaction, if the symmetrical ketone or the ketone, then it gives only one product, but unsymmetrical ketone is present, then there will be a two product. And remember, there is a migration of that R group. R may be as a alkyl group or the aryl group, and that which group is a migrate. Remember, in a Beckmann rearrangement reaction, it is a very important whenever you talk about the Beckmann rearrangement, the which group is migrate, the group which is a trans to hydroxy group, which is a migrate, so that you should remember, and the product is obtained. So that is somewhat about that Beckmann rearrangement reaction. Now this reaction is carried out in a acidic medium. The reagent is generally employed. Number one is a sulfuric acid, H2SO4, then maybe as a thionyl chloride, PCl5 phosphorus chloride, Al2O3, sulfonyl chloride. These are the some of the reagent which is generally used, these are the common reagent generally used in a Beckmann rearrangement reaction. And now let us see the general mechanism, general reaction, and after that we will see the mechanism of that Beckmann rearrangement. I think general mechanism we have seen. Here we are going to take some of the example which can symmetry. I think in a general reaction we have seen like this: RC double bond NOH, and this is R, means I am considering here as a, what we can call it as a symmetrical ketone, and this species is known as oxime. This species is known as oxime. Remember, this is a general structure of the oxime. C double bond NOH is known as oxime, or it is known as oxime derivative. And this oxime, if you remember retro, we already know that, right? If you look at as a retro of this, you are going to get C double bond O R, and plus another one is H2N and OH. Look at, this is a ketone, right? This one is a ketone, and this one is a hydroxylamine. So this is a ammonia derivative. When they together and they form very quickly ammonia derivative, which is always in a solid form, and we know that when the solid compound is obtained, the derivatives as some characteristic melting point is very sharp, and this is the oxime derivative. And that oxime, when treated with the in an acidic medium, generally H2SO4 is used in this in those reactions. And what you are going to get, remember, here you are going to get, now what is happening, let us see here simultaneously the mechanism of this. Here the lone pair which is present on that nitrogen can pick up this proton, and what you are going to get here are then C double bond NOH twice, and that R. Now look at here, when OH twice, look at the coordinate or look at the bond, that oxygen atom is a trivalent now, and therefore positive charge comes on that oxygen atom. And now OH, if you look at here, OH is a bad leaving group. When catalytic amount of the acid is used, that get protonated, and now it becomes as a good leaving group, and that good leaving group is the driving force for the migration of this R group. And now look at this R group exactly. Here actually the lone pair which is present like this lone pair, and now this group and this hydroxy group, they are trans to each other, and this lone pair and this group are trans. So in that way you have to remember, you always see the stereochemistry. So this nitrogen, we are slightly written like this because they are exactly opposite to each other, and that type of the structure is generally referred as a trans, and therefore this R is going to attack on that nitrogen atom, and OH water molecule get depart over here. And what do you get here? Now when it goes there, look at, I am writing here this R, then C, this C double bond, then nitrogen, and these are connected to the nitrogen atom. And when this bond is broken, what kind of the charge present on this carbon atom? It has a positive charge, means there is a carbocation. And now this water molecule, again what is happening here, this water molecule is going to attack on that carbocation, and you are going to get here R, then C, OH, I am writing like this, and double bond NR. This is a enolic type of the structure, and they further, what is going to happen, at an equilibrium, or this the N this CH internally rearrange and it goes attached to that nitrogen atom, and you are going to get here RC double bond O, then NHR. So this is a N substituted amide. This is known as a N substituted amide. Amide we know that, and general formula of amide is RC double bond O NH2. That is generally for the primary amide we are talking about. So this is a general mechanism, or what we can call it as a Beckmann rearrangement reaction. Now let us move on to the let us see some of the example of this Beckmann rearrangement reaction. Let us take one example. I am here writing this type of the example, C double bond O. Now is a zigzag structure, and zigzag structure why? Organic chemistry generally using as a zigzag structure, or why? Because it is a very easy, or it can save the time, or the clarity of the functional group is very clearly shown, so that these are the some of the benefits of that zigzag structure. And the organic chemist generally knows that, suppose this terminal carbon atom, and while writing as a zigzag structures, what are the things to remember? We are missing the carbon atom, we are missing the hydrogen atom, and every corner, if you look at here, this corner represent as a carbon atom, and chemists, organic chemists know that there are two bonds, so there must be as a two hydrogen atom. And look at here is a terminal, this terminal position also indicate as a carbon atom, and that carbon atom must attach or must carry 3 hydrogen atom. That also organic chemists know that, you all are knowing that. So now here what, this is a general ketone, and when this ketone is further treated with H2 hydroxylamine in a acidic medium, or no need of acidic medium over here. So what is going to happen? 2H from here and oxygen form. Oxime is a form very simply that you have to remember. Instead of that oxygen atom, you just put as a nitrogen atom, and this rest of the thing as it is, and so that this we have considered it is a unsymmetrical, and the IUPAC name of this compound, if you remember, 1, 2, 3, 4 and 5 is there. So that is a 2-pentanone. 2-pentanone. That is the IUPAC name of this compound. And the whatever the result, when ammonia, this hydroxylamine, the name of this reagent is known as a hydroxylamine. Hydroxylamine. This is a reagent's name, and when it is treated, form as a oxime derivative. How it forms? Let us see here, double bond N and OH. Then this rest of the thing remains as it is, and while writing as a zigzag structure, we are representing only as a functional group. And here why I am showing as a hydrogen atom? Because it is attached other than the carbon atom, and that's why it is shown over there. So that clearly indicates, and this derivative is known as a oxime derivative, right? This is oxime derivative we got, and this oxime derivative, suppose further treated with in a acidic medium, as usual, what we are going to get? This lone pair on that oxygen atom will pick up that proton, and what you are going to get over here, this one N, then OH2 positive charge, and here this one. And now there are the two possibilities are there, right? Now two possibilities One possibility is this one, when we because this form is a two other way round, when one and one we can write another way like this, double bond N, then OH2 positive charge over here you can write, and this one, because now when I am writing as that OH in this way also, or I can write that OH2 on that side, means two possibilities are there, because our starting compound that ketone is asymmetrical in nature, and as we know that the group anti means the group migrate anti to OH. Remember, group migrates anti to OH group. This is a very important sentence you remember as far as the Beckmann rearrangement is concerned. And therefore now if you look at here, if you observe this carefully, this group is migrating like this, and so that what do you get over here? You are going to get the product not like this. Now is this one, this, then I am writing this one, then what is that? Suppose is a double bond N, and then this one, right? 1 2 3 1 2 3. This is a propyl group, right? Now this is the one way, and the positive charge coming over here, and this is a departure of that water molecule. And here what is happening? This group, now this methyl group is migrated from here to here, and then OH2 is evolved during this process, and what the resulting compound will be this one, then double bond N, and this methyl group. Look at here, nitrogen connecting to as a propyl group, and here nitrogen attached to as a methyl group, and there is a positive charge over here. And now when the water is added here, H2O, what is going to happen? Here you will get this type of the double bond over here, and OH I am writing like this, nitrogen atom, and rest of the thing is this one. And here also the water molecule is going to add over there, so like this, and you are going to get this, then double bond OH I am writing like this, nitrogen, and this CH. Now this at an equilibrium, what is going to happen? This is a enol type of the form, or this is going to form as enol keto type of the form, and so that you are going to get O, N, then nitrogen atom here, 1 2 and 3, one hydrogen atom is there. So this one is a form near about as a 73%, and rest of this one, when it is converted into at an equilibrium, suppose I am showing here this one, so it goes like this, C double bond O, then N, H, and this CH3, and this we are getting only as a 27%. So these are the differences. You can clearly see there are the formation of the two mixture of the product, and when the mixture of the product, two products are obtained, there is always competition between these two. One is a major while another one is a minor. So here you can clearly see there are 73% of this N-acetyl type of the amide we obtain over here, and here is this one. So look at these two are generally, how do you distinguish between these two? By in a next means while studying as a spectroscopy, at that time we can clearly distinguish this and this, that from by using as a NMR spectroscopy, because here the signal whichever we are getting over here, this methyl group is a different one, and this, so by observing, by analyzing the spectra from their chemical shift value, we can, or the organic chemist can easily distinguish these two structures from each other. That type of the analysis we will see while studying as a spectroscopy. But here just remember two products we are getting and how one is a major and another one is a minor. Let us look at as another example based on this Beckmann rearrangement reaction, because we are discussing the Beckmann rearrangement reaction over here. So now let us move on to the next example over here, which is the next example. I think this will be the third example, that is a preparation of Epsilon Caprolactam. Third example will be this one, preparation or synthesis of preparation of Epsilon Caprolactam. Caprolactam, it is one of the, what we can call it as the important starting material or the raw material required for the synthesis of nylon 6 in a polymer chemistry, and therefore this Beckmann rearrangement reaction has a industrial application. Why it is, and now how that Epsilon caprolactam is a synthesized, so that we are going to study here from cyclic ketone, which on treatment with bases produces cyclic ketone, which on treatment with bases produces industrial application, as we know that, and therefore this Beckmann rearrangement reaction is highly important as far as the industrial application is concerned. So preparation of Epsilon caprolactam, how to prepare, what are the starting material, what they have taken, starting material is this one. Look at this one. You might be familiar, you quite familiar with this compound. What is the name of this compound? Most of you might be knowing. This is a cyclic compound and this is a ketone. So it is the name of this compound is a cyclopropane, cyclohexanone. This is the name of this compound, cyclohexanone. Cycle is there are 6 carbon atom, and therefore hexane, and last suffix is ONE, indicate as a ketone group is there. So in this way we can see the preparation of Epsilon caprolactam, right? Sorry, this is a cyclohexanone. Now when this compound treated with hydroxylamine, we know that this one H2N and then OH. What do you get over here? So now you are going to get resulting compound is obtained, so this one N, then OH, right? Then double bond NOH. This is a oxime derivative we got. This is a oxime derivative, and that oxime derivative further, when it is treated with concentrated H2SO4, what do you get? This is going to get protect over there, so that you will get this one. Now here double bond NOH2 positive charge over there, and now the rearrangement occurs, means this bond, this is which is anti to that hydroxy group, is going to shift from here to here, and this there is a expansion of ring, like right, and so you are going to get here. Now I am writing here is a nitrogen atom, then double bond. This is a bond 1, 2, 3, 4, 5 and 7, I think, right? 7 membered ring is formed. There how many carbon atoms are there? 1, 2, 3, 4, 5 and 6. So 1, 2, 3, 4, 5 and 6. These are the 6 carbon atom. Now when this bond is broken, so what is going to happen? There must be as a positive charge. Look at this one carefully. Got it? The 6 carbon atom remains as it is, only this double bond we have included into that, and now there is a attack of water H2O, right? And this water molecule is going to attack on this carbon atom, and after attacking on it, so we can write this double bond, then here OH we can write like this, and other thing remains as it is, right? So this is the symbol, means 1, 2, 3, 4, 5 and this one is a 6. Now this is a enol form that get converted into as a keto form. They are the tautomers of each other. You might be knowing, you all are knowing the tautomers means what? Tautomers. So here this double bond is going to convert in this hydrogen migrate from here to here. So internal rearrangement reaction takes place, and we are going to get over here this one. So NH, this and this carbon 6. Let me draw properly that ring, so that you can NH, and then this is a compound which we got, and this is nothing but as a what we can call as a Epsilon Caprolactam. So here double bond O, this is a alpha, beta, gamma, delta and epsilon we can call. So likewise this is a epsilon caprolactam, you can write epsilon caprolactam. Term indicate as a, this is a amide group in the ring form, so that type of the compound is called as a lactam. Suppose as a ester group in the ring form, that is called as a lactone, remember. And here lactam means there must be as a this type of the peptide. You might be heard about that peptide bond, right? In the what we can call it as the amide. In a peptide synthesis, you might have seen that peptide bond N. This is a very good bond when it forms. So this one is a preparation of caprolactam. So that we have seen. Now other example we are going to learn here. So let us see benzophenone to benzanilide. Benzophenone. Fourth example we are going to learn over here. Fourth example, let us see over here. The example number maybe as a 4, I think. So let me clean the board first, and then we will see that example over here. Now the other example in that fourth example, I think, preparation of benzophenone to benzanilide. First of all, do you know the structure of benzophenone? Right, acetophenone, everybody knows that the structure of acetophenone. So, and benzophenone means it is a aromatic ketone. On both sides there is a phenyl group. So that type of the structure is known as a benzophenone. pH, in short I am writing that phenyl group. representing with that pH. Here it is the shortest and the easiest one. And now when it is treated with hydroxylamine H2NOH as usual, now this is going to attack on that carbonyl group. Just remember O from here and H2 from here, they join there is a elimination of water molecule, addition, elimination, as we know that while studying as ammonia derivative. Here pH, then double bond N and OH, then this is a pH, right? This form, whatever the product here obtained, this product is known as a oxime derivative, right? Oxime derivative. This is oxime derivative, and with this oxime derivative further treated with acidic medium, what you are going to get again, which is going to pick up the proton like this, and you will get pH, then double bond NOH, to positive charge over there, and this is a pH, right? And now as usual, this is a symmetrical ketone. This is known as a benzophenone. The name of this compound is a benzophenone. And now look at symmetrical, so only one product is possible. And now this pH is going to attack on that nitrogen atom, departure of that OH, because OH is a bad leaving group. When it is treated with catalytic amount of acid, it get protonated, and that becomes as a good leaving group, and therefore this is a water molecule easily depart from this, and that is a driving force over here. And what you are going to get here, this pH, then double bond N, and this is a pH, right? And positive charge comes on that carbon atom, and now during that work of water molecule can attack at this carbocation, and you are going to get here pH, then here double bond N and this pH, here O and H I am writing like this so that we can show the tautomerism over. This is a enol form, and now we are going to get as a K2 form like this. And here we will resulting compound obtain C double bond O, then NH, and this pH, and this is known as a benzanilide. This is known as a benzanilide. So this is in this way we can prepare this compound. Now let us look at as another one, how will you prepare acetophenone to acetanilide. Now fifth example that we are going to learn over here. Let's see how, that is I think example number 5 we are discussing here. Example number 5, right? Example number 5. Acetophenone to acetanilide, right? So now, and everybody knows the structure of acetophenone, right? Acetophenone is this one, pH I am writing again, C double bond O and this CH3. This is the structure of acetophenone. In organic chemistry, you must remember some of the common compound which are using again and again in many reactions. So remember those structures while reading as again and again, you can able to remember that one. How to remember? So here generally we are using as a H2NOH. This is hydroxylamine as usual. And now what is going to happen? Again this oxygen atom and this H2 is going to remove, and you are going to get here pH, then double bond N, then OH and this CH3, right? CH3. And after that when it is heated with H plus, what is going to happen? The lone pair which is present over here attacking, and you will get here pH, then here double bond N and OH2 positive charge over there, and here is a CH3. Remember, there is a competition. pH is a trans to that hydroxyl group, and therefore it is going to migrate like this, and you will get here pH, then double bond N, not this. Let me clear here. Methyl group is remains here, CH3, then here double bond, then nitrogen atom and this pH, right? And now here is a positive charge, and now then treated with water is going to attack on that carbocation, and you are going to get here CH3, then this one OH, double bond N and the pH, right? And now as we know that this is a enol form, it's going to convert into as a more stable form, that is a this one CH3 double bond O, then NH like this, and you are going to get here NH and pH, and this is nothing but as a acetanilide, right? This is acetanilide which we got over here. I think with this we have seen a number of example of Beckmann rearrangement reaction, and in the next lecture, tomorrow's lecture, we will see the Beer-Villiger rearrangement reaction. Sometimes it is referred as a Beer-Villiger what we can call oxidation reaction. I think with this, let us stop today here. Remaining we will see in the next lecture. Thank you. Have a nice day.